are here to discuss on the course Advanced Design of Concrete Structure. Myself Amol Sawant, Department of Civil Engineering, KIT College of Engineering, Kolhapur. First of all, we discuss about the broad objectives of this courses. So, broader objectives of the course are: first, identify the provisions made in IS 456-2000, IS 3370-1984 and IS 1346. Second is develop the concept of yield line theory, and third is analysis and design of different RCC elements, water tanks and retaining walls. So today we will discuss about the first unit, that is flat slab, and the lesson is introduction of the flat slab, method of analysis and design procedure. The objective related to that lesson is analysis and design of RCC element such as flat slab. So what is flat slab? In common practice, what we design, we are casted the slabs which are supported by the beams, and beams are supported by the columns, which is known as slab column or slab beam design. But in many cases, due to that or due to the depth of the beam, we cannot get the required height or clear headroom. Specifically for public buildings such as warehouses, offices, public halls, etc. In such cases, the slabs are directly rest on the column, and such slabs are known as flat slabs. Means slab are not supported by the columns. The slabs are directly rest on the columns. So we delete or we eliminate the element of beam, and such type of slabs are known as flat slabs. Now these are the classification of flat slabs. First is flat slab, only flat slab which is directly rest on the see, this is the first flat slab which is directly rest on the column. Second is flat slab with drop panels, means some projections are made below the flat slabs and above the columns to reduce the punching shear of the column into the slab. So that is known as flat slab with drop panels. Next is flat slab with column heads. So in such cases, the top portion of the column is flattered, and the slabs are rest on that flattered column top, which is known as flat slab with column heads. And last classification is flat slab with drop panel and with column head, means some projections are made below the slabs and the top portion of the column is again flattered, and such combination is known as flat slab with drop panels and column heads. Next is, what are the advantages of flat slabs? So following are the advantages of the flat slab. It provides a large clear ceiling height. The construction is simple and economical because of the simplicity or simplified formwork is of easy to place the reinforcement. Third point is the plain ceiling gives an attractive and pleasure appearance. Fourth, in absence of beam, provision of acoustics treatment is very easy. And last, in general, flat slab construction is economical for spans up to 10 meters and relative light loads. Means for more heavy loads we cannot design. We are able to design the flat slab, but generally it is used or economical up to 10 meter span and relatively lightweight loads. Now what are the advantages? The advantages of flat slabs are as follows. The stiffness of the structure comprising of flat slab and column is much lesser than the slab beam column construction, with the result significant bending moment due to horizontal load can be effectively transferred. Means in flat slab in column beam design, the horizontal loads cannot be effectively transferred. Bending moment which is related to the vertical downward load is directly transferred to the column, but we cannot consider the stiffness of vertical load. Second disadvantage is, for this reason flat slab construction is used in low rise and medium size building or medium rise buildings which are not tall enough to subject a larger horizontal wind load, because in the flat slab we are considered only vertical load, not the horizontal load, and the wind load is horizontal wind load. Hence the design parameters are not sufficient to take the stiffness of horizontal wind load. That's why it is major disadvantages of this flat slab. And third is serviceability problem arise with excessive long term deflection of such relative thick slab. However, they are not so serious if drops or column caps or column heads are provided. Means the thickness of slab cannot serve for a long time, but if you provide the drops and column heads or any of that one, that is column drop or column head, it is not that much serious problem in the design or in the serviceability. Next, some important terms in the flat slab. So the thickness of flat slab and the size of drops and column heads may be provided or proportionate as per the suggestions given in IS 456-2000, clause number 31.2, page number 53. These are the clauses given by IS 456. First is thickness of slab. It has to be noted that the maximum or minimum thickness, it has to be noted that the minimum thickness of slab should be 125 mm and the longer span should be used in the calculation of L by D ratio. So generally the thickness of flat slab is also calculated by using our normal formula, that is L by D ratio, or L by D is equal to constant. But for that, L is nothing but the longer span of the flat slab, and whereas the minimum depth of slab should not be less than 125 mm. These are the provisions made by IS 456-2000. Second is drop panel. Drop panels are used to reduce the shear stresses around the column support. A drop panel should be rectangular in plan. Now, how to calculate the depth of drop panel and etc. we will discuss at the time of problem solution or design procedure. Next is column head. Occasionally the top of the column will be flattered outwards. The flattered portion of column is called as column head or column caps. It is provided to increase the punching resistance and reduce the clear span of the column. It is usually proportionate to the 1/5 but not more than 1/4 of the shorter span. Its height should not be less than 150 mm. Means whatever the flattered portion on the top of the column, the depth of that flattered portion should not be less than 150 mm. Next is shear cap. Now this is the only concept, we are not using that concept while designing the flat slab. Shear cap, the ACI code allows shear caps, also called as shear capitals, which are projection beyond the slab similarly to the drop, but not satisfy the dimension limits of drop panel. Okay, this is the only concept. Next, behavior of flat slab. Now up till now what we discussed, what are the advantages, disadvantages, what are the major terms used in during the design. Now what is the behavior of flat slab? Flat slabs or flat plates do have beams. Their behavior don't have the beams. Their behavior is identical to that of two-way slab with beams. The behavior is same. The broader strips of the slab centered on the column lines in two orthogonal direction designed as a column strips. Normally these column strips are act as a broader beams. Hence there is no behavioral difference between flat slabs and two-way slabs with beams. Did you get it? The behavior of two-way slabs with beams and flat slab is not differ. The behavior is same because the border strips of flat slab centered on the column lines in two orthogonal directions are known as column strips, and these column strips are generally act as a broader beams. The strips at the mid of the slab which do not pass through the columns are referred as middle strips. So, middle portion is known as middle strip. A simplified scheme of column strips and middle strip of a typical flat slab as adopted in various courses of practice. The column strips bears as a continuous beam supported on the column. The typical deflected shape of interior panel of the flat slab is also shown in the next figure. See, this is a flat slab supported by the columns without column head. If you consider this middle column, see figure B, here the load is applied on the flat slab. Due to that load, the flat slab is deflected like this, and due to that deflection, the formation of punching comes into picture, and this punching failure is shown in the next figure. So, to avoid that punching, we want to provide some drop or column head, and when you provide the drops and column heads, it is not much serious problem while designing the flat slabs. Next is mode of or method of analysis. So, first is direct design method and second is equivalent frame method. Now, today in this lecture we discuss about the direct design method. We will see the equivalent frame method in the next lecture or in the next lesson. So, first method is direct design method. So, what is direct design method? It is a semi empirical method, and as per clause number 31.4.1 as per IS 456/2000 page number 55. It is applicable only when the following conditions are met. First, there should be a minimum 3 continuous span in each direction. It is because the negative moment at interior support in a two-way structure will be exceed the value of given in the code. Second restriction or second condition is the panel should be rectangular, and the ratio of longer to shorter span within a plane or within a panel should be or should not be greater than 2, like a two-way slab rule. L1 by L2 should not be greater than 2. This limitation excludes one-way slab. If the slab or the flat slab is directly given as a one-way slab, then this rule is excluded. We can directly use this method to analyze the one-way slab. But if the slab is rectangular slab, then the L by D ratio should be less than 2. What is L by D? Longer to shorter span. Next, the successive span length, center to center support in each direction must not differ by more than 1/3 of longer span. Means the column positions or center to center distance between the columns should not be differed in any direction or in each direction, and if it is differed, then the difference should not be more than 1/3 of the span. The end span may be shorter but not longer than inner span. Now, what is interior, what is exterior, we will discuss it later. Columns may be offset to a maximum of 10% of the span in the direction of offset. Load or loads must due to gravity load only, which are uniformly distributed load on the entire panel, and the design imposed load must not exceed 3 times the dead load. Now, see, this is a clause which we will discuss in the behavior, that the slab is only designed for the vertical downward load or gravitational load, which is act in the form of UDL. We are not considering the wind loads or horizontal wind loads acting on the slabs or acting on the building. Hence, this is a major disadvantage of flat slab. The limit of the next point is the limit of the ratio of imposed load to dead load is to take care of effective pattern loading. Next point, the total static moment in the distributed longitudinal and transverse among the various regions of the slab based on the panel and span. Interior spans as per clause number 31.4.3.2 IS 456-2000, the distribution in inner panel is simple and it is approximately equal to the fixed end beam moments. Thus, the support moment MS is assumed to be 65% of the total static moment and the span moment or span positive moment to be remain 35%. These moments are further divided into column and middle strips as discussed later in the session. Did you get this second point? The total moment which is calculated as per clause number 31.4.3.2, page number 55, IS 456-2000, that total moment is distributed into two parts. First is negative moment and second is positive moment. Negative moment act at the support, whereas the positive moment is act at the mid of the span. So 65% of the total moment is act as a negative moment at the support, whereas the 35% remaining 35% is act as a positive moment at the center of the span. Exterior panels as per clause number 31.4.3.3, the distribution of total static moment in the external panels or external span depend upon the support conditions and relative stiffness of the column and slab. Now, how to calculate the support conditions and relative stiffness we will discuss when we discuss the design procedure of the external panel. In general, you want to calculate the following coefficients to calculate the moment distribution in external panel. First is external negative design moment coefficient, which is known as C1, 0.65 upon 1 plus alpha. Interior negative design moment coefficient 1 minus 0.01 upon 1 plus alpha. And last, mid span positive design moment coefficient is equal to 0.063 minus 0.28 upon 1 plus alpha, where alpha is equal to 1 upon alpha c, that is Ks plus Kb upon summation of Kc. Kc is nothing but the flexural stiffness of the, Ks is nothing but the flexural thickness or stiffness of the slab. Now, what are the equations, what are the notations and what are the calculations we will discuss while designing the external panel slab. Now, thank you. This is the first section or end of our first section. We will meet in the next section to discuss the equivalent frame method. Thank you.